This is MRV, it's the Modular Robotic Vehicle. It's an all-electric vehicle built here at JSC to learn some new technologies we can apply for future manned rovers for the moon and Mars. The concept is a city car, so it's built like a smart car size, two-person. It's all electric. Top speed, the propulsion motors will get it up to about 40 to 50 miles an hour and uses what we call by-wire technology. So there's no mechanical linkages, say between the steering wheel and the wheels of the car, the propulsion or the brake pedal. It's all sensors in the steering wheel and pedal units that tells a computer in the back how to manipulate electric motors throughout the vehicle. So that force feedback's in the steering wheel. We also have the pedals are specially designed to feel as much like a real car as possible. Each wheel module is modular. That's what we call the Modular Robotic Vehicle. That allows the vehicle to drive sideways, diagonal, and spin on its center axis, which makes it pretty unique and highly maneuverable in a parking lot or traffic. Each of those wheel modules consists of a propulsion motor inside each of the wheels, so it's a hub motor in the wheel itself. There's a brake motor to the side of that, and then above it there's a redundant steering motor that controls the steering about plus or minus 180 degrees. So there is a cooling system in the vehicle that is basically pumping fluid through all the avionics. So that cooling system is something that we can apply to future vehicles. So you can drive MRV just like a regular car. So two-wheel front steering, just use the steering wheel, and it feels just like you would the car you drive every day. I can put it in some different driving modes, one of which is called omnidirectional. And in that case, I use the steering wheel to help me control the vehicle. So I can combine these two inputs, the steering wheel and the joystick, to get what we kind of call a drifting motion, to where it looks like I describe it as driving on ice, but you've got full control. And the vehicle can drift sideways and do some of the more unique motions that you wouldn't see in a traditional automobile. So we wanted to develop a system that we call fail operational. It's where one of those things can fail, a wire fails or a computer fails, and there's a redundant system that immediately takes over control and allows me to safely move the vehicle off the road to a safe spot. And that's something we'll want to have for the moon or Mars. When you're on Mars driving around and you have a failure, you need to have redundant systems that can take over control and allow the astronauts to safely get back to their habitat or wherever they need to go.